All right, let's look at S14, where we're going to compare linear functions when they're presented in the forms of graph, tables, and equations. So we have function A here and B, and we know this is a function because it passes our vertical line test, where every x has only one y, one and only one y. So it asks us which statement is true: the slope of function A is greater than the slope of function B, or the slope of function A is less than the slope of function B. Now, since we have a graph here, we can either choose to leave this as a graph and turn this function B into a graph where we can compare the steepness of the line. So does the line go like this, or does it fall down like that, or does it go a little bit more out to the right? But since this is in our slope-intercept form, I'm going to take function A's graph and turn it into the slope-intercept form. And we kind of rehearsed that in some earlier skills that we did. So I have on my graph here, I see that my y-intercept is 2. So I'm going to put this graph into the slope-intercept form. My b is -2, and then I'm just going to look at my slope, which is rise over 1, run. So go up 1 over 1, up 1 over 1. So my slope obviously is positive, and it's 1. So my equation would look like this: y is equal to 1x minus 2. This is the graph, and I'm going to compare it to y is equal to 4x minus 5. Well, we're just comparing the slope portion. So 1 is obviously less than 4, and 1 belongs to function A, and the equation belongs to function B. So therefore we can say that function A is less than the slope of function B. So now we have a table. Function A and B are linear functions. Which statement is true? The slope of function A is greater than the slope of function B. The slope of function A is less than the slope of function B. So we have, let's go ahead and write for this one, the function A, we're going to write in y-intercept form, or slope-intercept form rather. So my y-intercept is -3, and it looks like I'm going to go up 1, 2, 3, 4, and to the right 1. So my slope is 4. Now, let's go to function B, which is the table. And we want to look at the change that happens here. So I've got two ordered pairs, right? I've got -3, -2 as an ordered pair, and then I've got -1, 0 as an ordered pair. I'm going to use the slope-intercept form, or the equation for slope. Guys, excuse me, it's 7 in the morning and I'm doing this. So I've got 0 minus -2. So I did this one and this one, over -1 minus -3. So -1 minus -3. So 0 minus -2 is 2. -1 minus -3. So basically I'm adding those. -1 plus 3 is 2. And so my slope is 1. So this would be y is equal to 1x, and I really don't need to know my y-intercept because I'm just comparing the slope. So for function B, my slope compared to the slope of function A, well, the slope of function B is less than A, so we'd have to say slope of function A is greater than the slope of function B. Do one more. and then I'll call it quits because I got to get to work. Y'all will be waiting for me. Function A is equal to y is equal to 5x minus 5. And then we're going to do the same thing for the table. And I just like using the two ordered pairs because it just makes it easier for me. This time, I'm not going to write this as ordered pairs per se. I'm just going to use the table. So I'm going to do, I know this is y, this is x2, y2, this is x1, y1. So I'm going to say negative 5 minus negative 23 over negative 1 minus negative 7. Well, this turns into negative 5 plus 23, because a negative minus a negative is a positive. Remember, double negatives in English means positive. Minus negative 7, that means plus 7, so negative 1 plus 7 here in the denominator. Well, 23 minus 5 is 18. My larger number is positive, so my answer is positive here. 7 minus 1 is 6, and my larger number is positive, so my answer will be positive. So my slope is 3. Let's compare. We're comparing 3 to 5. So the slope of function A is greater than the slope of function B. Is that a true statement? So is 5 greater than 3? Well, yes, it is. All right, hopefully this was helpful. If you have questions, please don't hesitate to ask. See you later.